Hello, everyone. Good morning, good afternoon, good evening, depending on where you are in the world. Thank you so much for tuning into our masterclass series. Today is going to be focused on security and observability, and we are joined by Nigel and Joseph from Tigera. Guys, you want to give a quick hello?
Yeah, hi everyone. My name's Nigel. I'm Solutions Architect here at Tigera. I'll be joining Joseph, but I believe Joseph's going to lead most of the session, so he'll be the person to ask questions too.
Thanks, Nigel. Thanks, Luke. Hi, everyone. My name is Joseph Justus. I'm a technical marketing engineer at Tigera. So excited to join you today. Hopefully you find it very useful for you. Thanks.
Excellent. So I'm really looking forward to this one. I think there's a lot of excellent stuff that is lined up for us. A very important topic as well. And for those of you that are joining for the first time, we'll go over a little bit of Crowdcast etiquette or administration, just so you know how to make your way around everything going on this platform. But first, I want to start off by letting you know that there are some active polls. So please do check those out. We'd love to get some feedback from you and just a little bit of insight. It's just helpful for us, one way of actually knowing how we can tailor our content to make it more valuable, but also just insightful information for us as well, especially for Nigel and Joseph, who are from Tigera and who are actually going to be spearheading this particular session today. So please give some feedback on the polls there. One of them is just to get an idea of what your current role is in your organization. So we don't have any DevOps engineers or security ops engineers, which is a little bit funny. I thought it would attract a lot of people in that role, but it's all good. I see we've got a couple of software developers, some solution architects, and people that fall in the category of other. For those of you in the category of other, please feel free to actually let us know in the chat. You can drop what your particular role is. We'd love to get that information as well, just so we have an idea of who's tuning in and what their particular role is. And like I said earlier on the chat, you can also just give a greeting. If you're comfortable with it, you can let us know where you're tuning in from. We love to see diverse distribution from across the globe. Hopefully we have people from Australia, people from North America, Europe, Asia, etc. I doubt we have anyone tuning in from Antarctica, but I'd be happy to get that surprise. Okay, cool. Just before we get started, I'm going to let you know that this particular session is independent or standalone. And by that, I mean that if you have not been attending any of our previous Kubernetes masterclass sessions, that is totally fine. You'll not be hindered from getting a lot of value from this particular session in and of itself. But it does fit within a bigger picture, a series that we're dealing with at the moment, which is cloud native at scale. And we're exploring different dimensions of scaling in the cloud native space. And those different dimensions are cluster management at scale, applications at scale, utilization at scale, and deployments at scale. And right now we're currently in the applications at scale section. And without further ado, I'm going to hand over to Nigel and Joseph. They'll probably reintroduce themselves again because there are a couple of people that might just be getting settled, etc. Just for those of you who don't know me, I'm Lukonde Mwila or Luke Mwila, and I'm a senior technical evangelist at SUSE, and I'm a part of the SUSE and Rancher community team. You can see the big green button right at the bottom there, which is a call to action. We'd love for you to join the SUSE and Rancher community. It's a great way for you to actually join other cloud native enthusiasts and practitioners on this particular journey. And there's a lot of awesome material that we have in there, on-demand resources, technical articles, courses. So if you're new to Kubernetes or you're experienced in Kubernetes, there's still a lot of valuable content over there. And you can also get involved with sharing knowledge. Great. So I can see some awesome representation. I see Costa Rica and Norway. So please do keep it coming, people. California as well. But without further ado, I'm going to hand over to Nigel and Joseph.
Thanks, Luke. So let me start with sharing my screen. Just confirm if you can see my screen. Nigel or Luke, can you just please confirm if you can see the screen?
I can see your screen.
Can see your screen, Joseph.
Okay, perfect. So thanks everyone for joining. Our today's masterclass is security and observability for cloud native application using Tigera and Calico. We will discuss today what makes securing cloud native application so different than the traditional application. We will see different techniques of security and observability using Calico products. We will discuss different use cases: north-west control, north-south control, east-west control, microsegmentation, and observability. We will be using different tools and techniques like DNS policies, dynamic path capture, host protection, and more. So I'm so excited to share all this with you. So let's get started. I think already Luke introduced me. Thanks for that. My name is Joseph Justus. I'm a technical marketing engineer at Tigera. I've been working in that field for more than 12 years. Most of my experience with virtualization vendor and networking and security. I'm very passionate for the last 2 years working on cloud native application and container security. So our agenda today, we will start with a very quick introduction about what we're gonna do. I will give you a quick overview about the lab setup, what we have, what application we have, how we deployed our infrastructure, and after that we will connect one of our RKE clusters to Calico Cloud. Just to I'll just start with this step because it takes few minutes, so we save some time, and during this time I will give a quick presentation about Tigera and Calico, what the relation between these two names, what we do exactly, and after that the fourth section is a demo and lab, and I think we're gonna spend most of our time on this section. We're gonna stop for 2 Q&A. The first one will be after section 3, and after completing our lab, I'll make sure to give some time for questions. So feel free to send a question and anything on the chat or in the Q&A, and we will stop to answer all of your questions. So starting with our master class today, as we mentioned, it's security and observability, starting with what we have in our lab today. So our lab consists of two applications. The first application is a hipster shop application, which is developed by Google. And hipster shop is a cloud native microservices application. It consists of like a 10 tiers, 10-tier microservice application. The application is mainly web-based e-commerce application where user can buy product and add to cart and just do whatever you can do on any normal e-commerce application like Amazon or anything else. So as you can see, it's we have mainly front end where all the traffic is coming from internet and load generator. When you add something to the cart, it goes to the cart service, and we have a cache there. So in case you're shutting down or closing your browser, it saves or cache all these items. We have a recommendation service, application catalog service. Once you check out, you use the checkout service, and that talk to the payment service and shipping service. So it's very handy app. Thanks Google for creating that for us to use it for demonstration. We are on this application in the default namespace, by the way. The other application is just simple a development workspace in a dev namespace, consists of a CentOS pod talking to Nginx pod. We use that for testing. And during our session today and during the lab, we will see how to control the traffic between the different namespaces, and inside the namespace, how to control to do egress access control between bots inside these namespaces and external resources. We will see an example for applying compliance report and alerts and doing some kind of troubleshooting using the dynamic path capture. And once this is a different view for the hipster shop application from our Calico UI. So this is something called service graph, where it just demonstrate the different services in your application and the traffic, what is talking to what exactly. And as you can see, all these green arrows mean that the traffic is allowed. Once you have any traffic denied, it will be converted. We'll spend some time talking about service graph. Just I wanted to give you overview about what we will be doing in our in these 90 minutes, just to keep you excited. A quick overview about our lab today, or our infrastructure. So we have an RKE cluster consists of 3 nodes. We deploy that using Rancher server. So we deploy the Rancher server, and from the Rancher server, we build a cluster consists of a master node and 2 worker nodes. From this point, I would like to invite you to sign up to Calico Cloud, and just you will find an option to start a free trial that gives you 14 days to connect any cluster you have. If you have any cluster, to just connect it and start. Once you complete the session today, you can try that with your own. We will give you a guide for all the steps that we will do today, so you can try that with your own. Once you log in, you can add your cluster. We integrate with a different cloud provider and different distribution, but we are focusing today on Rancher. So definitely we will add an RKE cluster today. From this point, I can start doing that on my cluster. So I have here is my cluster. I just need to export the kube config.
Hey, Joseph. Sorry, do you mind just zooming in a little bit on your terminal?
Yeah, sure. Is that better? Just I'm making the text bigger till you tell me.
Yeah, I think that looks good for me.
Much better.
Okay. So yeah, as you can see, we have a master and 2 worker nodes. And just to save time, I will start with connecting this cluster to Calico Cloud, and see how it will work. So to connect to Calico Cloud, I will, as I told you, you just need to go to Calico Cloud. And as a new customer, you may need to just try the free trial here. That will send you an email for activation, and after that you'll be able to log in if you are existing user like me. So you just log in, and we will talk about everything here and how we will use that. But for now, let's connect one cluster. So from managed cluster, I will connect. I will select RKE Rancher cluster, and it's very simple. It gives you one command to run. So just one curl script, one bash script we curled and install it. So let's go back to our cluster. That will take 4 to 5 minutes to complete. So once completed, we will be able to work on our cluster. From here, I will go back to my slide and continue working on my slide. So talking about Calico and Tigera, and what is the relation between Calico and Tigera. So Tigera is the inventor and maintainer of Project Calico. Sorry, guys. Okay. Tigera is the inventor and maintainer of Project Calico. And Project Calico, if you are aware about it, is the most adapted open source container network solution for networking and security. Um, we have a lot of customers who are running Calico open source or our commercial version. In fact, 1/3 of all of the Kubernetes workload run on Calico, either the open source or the commercial product. As you can see in our portfolio, we have a quite big customer in a different industries. Our customer list included Fortune 500 customer. As you can see, some logos here like Visa, Bloomberg, AT&T, and more. We also have a partnership with all or most of the cloud provider and most of the distribution to run Calico Cloud. We are just focusing today on Rancher, but it's nice to mention that we have a partnership with most of the cloud providers and distribution. At the moment, we have 2 offices in California and 1 office in Canada and 1 office in Ireland, where I'm based. Next, the project Calico has got widely adapted because of its scalability and flexibility. It has built to be a pluggable data plane or pluggable CNI, which can run on a different data planes based on what you would like to use. So if any new technology arises, we can easily add it to our data plane. A few months ago, BBF was added to Calico as well Windows data plane. This is an additional to the standard Linux IP table and IP sets. And recently we have added the support for VPP data plane. It's still in tech review that has been launched a couple of months ago. The Calico network design is very simple when you look from the design perspective. We allow you to configure layer 3 network without any encapsulation. And for other users, for other use cases, when you can't enable layer 3 without encapsulation, you may need to have an overlay network. In this case, we support IP overlay and VXLAN overlay. Our product has been tested on a scale to the limit of Kubernetes. And because of the network design, which relies on BGP to configure the routes between the Kubernetes workload, it allowed us to scale quite fast than other CNIs. As I mentioned in the previous slide, it has been adopted by most of the cloud providers and distributions, and you still have option to use some other cloud provider CNIs, and we add the security part on top of that solution. So in this slide, let's have a look on the difference between the traditional application and the cloud native applications. What we are used to with the traditional application is having a client server architecture where servers are running on virtual machines, and you have a cluster or servers with client connected to them. With this traditional client server architecture, you will find that host and VM is the most granular component. And because of these VM most probably have a fixed network identifier, which is the IP, traffic can be easily controlled using the perimeter-based component like firewall or your network firewall. Also, the network-based monitoring tool will be sufficient in this scenario because you have a network identifier, you have a fixed IP, so you can control source and destination and protocol and port. But the cloud native is in the right side is completely different for a variety of reasons. If we look at it from the architecture perspective, you will find that microservices is the most granular component. And once traffic leaves the host, it will be NATed with the host IP, which makes it difficult to trace the traffic and enforce security. So in addition to that, the microservices are very dynamic and ephemeral. So it requires a built-in granular security and distributed monitoring with Kubernetes context. That's why we can't use the same methodology or the same way. So pods and containers are very ephemeral, very dynamic. Doesn't have a static IP, and that makes it very different and challenging to use a traditional component to secure it. And if we have a look on an example of a cloud native application, um, you'll see that workload in the data center will likely be behind security gateway that filter the traffic coming through the perimeter. And microservices running in this Kubernetes cluster are also likely to have one or more dependencies on that. So you would have a SaaS service like Salesforce, or anything you connect to run your application. You may have some legacy database or legacy application still in your data center, on-prem data center, that you need to connect. You may need to connect this pod to a third-party API or a third-party or any other cloud service like AWS, Azure, anything else than where you run your Rancher cluster. And that generates some challenges on the security and observability level. So from the security point of view, you need to secure ingress and egress from each microservice. You need to secure in cluster microservice communication. You need to enable defense in depth for microservices and the host to host, and at some point you need some automation to automatically detect and isolate and purge malicious actors. On the observability level, we still have some challenges, data silos, the amount of the volume of the granular data that we collect from the cluster, alerts and logs and traces. All this amount of data needs to be stitched together, and absolutely using the traditional monitoring ways with lack of service level observability and lack of Kubernetes context, that will not be the optimum solution in this case. So let's have an overview on how Calico can help DevOps and SREs to observe and troubleshoot Kubernetes cluster faster. So the first point will be implementing ingress access control using Calico network policies. You can define fine-grained security control by specifying which service can talk to each, and vice versa. As we go through the examples, you will see how Calico can help you definitely with that. As your microservice distributed across different nodes, and it's very dynamic, you will need a tool to help you to detect and prevent intrusions. So you will also need to deploy your network policies very fast and very organized and structured in order to be able to protect your containers efficiently. And finally, you need some tools for troubleshooting, like packet capture, and we will see how we deploy packet capture as a code. So you don't need to exec any pod and have exec privilege and to run something in the bot to capture the traffic. And I would say also a lot of DevOps and SREs who are new to the cloud native architecture, always complain of being blind and they don't know how servers talk to each other, especially when the environments start to increase and every day dev team will be deploying a new service. So Calico will help you to tackle this problem by providing tools like service graph, and where we saw that in the beginning, and flow visualization that will give you more visibility into your cluster to understand what is talking to what, and if there's any problem, where's the block, where's the bottleneck. So if we break down Calico capabilities, we can summarize it up in 4 pillars. So within these buckets, you have most common features for each use case. So we will talk about north-south control, and in north-south control, we have a universal firewall and SIM integration using egress gateway. And the idea of egress gateway that you can assign a routable IP to a namespace, so or a both, for example. But if you're assigning an IP for namespace, you can control or you can use existing firewall to apply rule to allow and deny traffic coming to this namespace. This is one of the method that we use to control north-south traffic. You can use also DNS policy, and we will see how we will use the DNS policy. And the DNS policy is just the idea of running a network policy based on FQDN, which is something very unique to Calico. And as well, we will see how to control, how to do an access control for ingress and the egress traffic on the pod. For the east-west control, we do application level service control, microsegmentation, host protection. We'll see all of this. I don't want to spend much time on describing each capability and each feature, as we will go through most of these capabilities in our lab. But if you want to stop in any feature, just don't hesitate to ask about it. For security and compliance, we support compliance for most of regulations, BCI, SOC 2, HIPAA. We do intrusion detection and prevention. We do encryption on the node level. From the observability side, we have a dynamic back capture. We do a dynamic service graph and the flow visualization. So I will stop this. I don't want to spend more time on the slides. I do prefer to spend most of our time on the lab. Just before starting the lab, I want to stop for a few minutes to ask if you have any questions.
Hi, Joseph. The only question I saw coming in the chat there a while ago was not a technical one, but it was regarding the content. Would the slide deck be provided to all users after the session? I assume this is shareable content.
Yeah, I think Luke can answer that if that will be shared with the users or not.
Yep, absolutely. And also this particular session is being recorded as well. It will be available on demand afterwards with the exact same link.
Okay, that's great. Thanks, Luke. Okay, so if there's no other question, I think we can start our lab. Okay, so as you can see that the cluster has been successfully connected to Calico Cloud. I want to see how much time it took. Let's show the timestamp. And oh, for some reason it's okay. So we started at 16:15 and it's completed. it was around just a few minutes here. It's not showing the exact time. I'm not sure that this is the correct time here. But it's yeah, usually it takes just 4 or 5 minutes. We spent like 15 minutes on the slides, and we found that the cluster is up and running. And let's just remove the timestamp. Back to just I want to pick one thing from the slides. Okay, so all the steps that we will go through today, you can find it on this GitHub repo, github.com, Joseph Yusuf Tigera RKE repo, and if you need more information about how we build the RKE cluster, you can also follow the steps in this repo by Nigel. That will give you more information about how to build that setup, exact same setup from the scratch. We are not building the setup from scratch here to save time, but you can find all the steps in this repo from Nigel. And so now let's open the. Okay, so this is our repo today. We have around 9 modules. We already completed the first module. So the first module is just to connect the RKE cluster, and the RKE cluster is already connected. If I join to Calico Cloud, I already joined. Let's get the name of the cluster. It's end with ZBC19. Okay, so as you can see, this is our cluster. It's already connected, and I always prefer to give it a kind of identifier. So I will add some label to that cluster. Just owner, I would say Joseph. Save label. I can add another label like environment, RKE workshop. Okay, so I'm just giving a label to identify, because this is our environment, and we have a lot of clusters here. Back to our repo. Moving to the second module. The second module is to configure our application. So in this, the goal of this module is to deploy and configure the demo application. We will deploy 2 tiers, and I will describe now what is the tiers. The tier that I will deploy is the security and platform. After that, I will deploy a kind of DNS policy. I just need to allow all the communication between all the bots and the core DNS. And most probably that will be a requirement for all of you and for all of the customer, because the next step I will be blocking all the traffic and start to allow only the traffic that I want. Here we have the manifest file for the 2 applications that I'm gonna deploy, and I will deploy some compliance report and some global alerts that I will use it later in a different module when we talk about the compliance report and global alerts. Just let's first clone okay. I think it is Reboot. And I'll move to this level. I'm not sure if I need a kube config git nodes. Okay, yeah, I just need to export the kube config file. Okay, and now we can see our nodes. our bots. Okay, and all looks fine. Okay, that's great. So from module 2 here, I will the first thing I will deploy 2 tiers. So the tiering in Calico, when you go to your cluster, you have something called the policy board, and this is a place where you deploy the policies. And by default, you have a default tier, but you have the option to add new tiers. So imagine that you have in your company, you have the security team, you have the platform team, you have the DevOps team. You can create a tier for each team to give to set their own policies, and we can use our back to give specific people based on their business unit and their functionality to access to a specific tier. So the security team, they should have only access to the security team, and platform has access to the platform tier, and so on. So let's just deploy tiers. You can see now, once I just run the command, we have now security and platform tiers. How that traffic filtering work? So tiers work from left to right. So when the traffic come, it get evaluated for the security tier first, then platform tier, then the default tier, and it get evaluated from up to down. So as you can see, each policy would have a specific order, and each tier also has a specific order, and the lower order get applied first. So if we are creating a policy to block all the traffic in the security tier, so that will be applied even if you are allowing the traffic later on the platform. And that explain why we would start by setting the security tier in first, because most probably anything applied on all the environment globally from the security team should be applied first. So I have applied the security tier. I will deploy. Just before applying anything else, I want to stop here and view what is in the YAML file. As I told you, everything is Kubernetes context. So the API version is just the Calico project API version, and the kind is tier. And in the metadata, we set the name of the tier itself, and we give it order, and that's it. It's very simple. Now let's deploy, or what I created a DNS policy to allow all the DNS traffic uh, from all the bots to core DNS in your Kubernetes environment. And again, so the type of this policy is something called global. And global policy in Calico mean that this policy is not specific to a namespace. It applies to any namespace, and that makes it easier when you have a kind of policy like this one. You know, to allow DNS traffic from any namespace to your core DNS. So this is something global. So you just need to run it once, and you don't need to add a new policy for each namespace. And again, we give it an order. We are allowing UDP for port 53, and we are selecting port that has a label called kubedns, which is our core DNS. And if we go to the UI, you can see that has been applied in the platform tier. I think here we identified that the tier should be platform. And the endpoints, we have 29 endpoint, 29 bot matching this policy. And so this is applying on 29 bots in your environment. The next, so we just deployed the base policy. now we need just to deploy our application. Okay, so we simply deploy two applications. This is the dev one in the dev namespace, and this is the hipster shop from Google, the one that I described first. It's the bigger one with 10 tiers of services and endpoint and front end and load generator. I will just deploy this manifest file to that I will use it later on, but I will not talk about it now. And now we are ready. I think we can move directly to the next module. So the next module is just how to control the traffic between these namespaces. And the goal of this module is to leverage network policies to segment the connectivity within the cluster and prevent known actors or prevent unknown traffic between namespaces. So, for example, you don't want to allow traffic between a development namespace and production namespace where you have the hipster shop or anything else. Yeah, just I have a quick requirement here. Just need to install the curl command or curl in the load generator. I'll just need it for testing. Let me do it manually. Yeah, the load generator is still initiating. That's why I'm not able to exit that and run any command. Yeah, load generator usually sometimes takes longer both initializing. Okay, it's running. Let's copy that again. Okay, so I now have curl installed in the load generator pod where I will be using this pod for testing. Before doing any change, I want to test connectivity between the workload within each namespace. So using this command, I do exit to the dev namespace to the CentOS pod, and I will try to curl the Nginx pod, which is the same in the same namespace. And everything's allowed, as you can see. It's 200 apply. This is on the other namespace, so we are exiting the load generator and trying to curl the front end service, and the reply is 200. Okay. Now let's try to test the connectivity across namespace and see what's going on. So I'm from CentOS. I'm trying to curl the front end, which is in the hipster shop namespace. Again, it is working, and that one is the other way. It should be working as well. 200. Okay. And finally, I will test the connectivity externally between from the CentOS to Google. Just to see if I'm able to access external resources or not. And it's fine. And from the load generator in the hipster shop to Google, and it is okay. So now I'm sure that everything's allowed, and so I'm ready to proceed to the next step, is to apply default deny. But I will not apply default deny directly. I will just run it in something called staged. So let's see what in this manifest file. Okay, so this is a network policy, a global network policy. I'm giving it order 2000, and I'm just denying all the traffic. As you can see, that the kind is called something called staged, and the idea of running staged network policy is to actually, this policy will not block the traffic, but will report what will happen once you apply this policy. So you can see, if you go to the UI, that we will start to see here in the dashboard some traffic blocked or denied by the default deny policy. And if you go here, you can see that the default deny is in staged staged state. Staged state, you can see that it is reporting what traffic will be denied, but it's not actually denying. And this is very useful just when you introduce any new policy or any new change, that you need to check what will be the impact of this policy. So if you are expecting that this policy will be allowing all traffic and not denying anything, and for some reason you can see some denied traffic, so you know that there's something wrong with this policy and you need to review it again. So it's very handy, and just to make sure that we don't have any or to generate some traffic. I'm just generating some traffic to be able to see more. Yeah, here you can see that this denied traffic is increasing. Okay, so that just to simulate that how it worked. At the same time, we are getting 200 okay HTTP response. That means that the traffic is allowed; it's not denied. And so now we need, okay, so now the next step, just before applying or denying all the traffic, I will allow the communication between the namespaces or between the pods. So I have some policies already in place here. I will apply it first. Okay, so I have created some policies. If you go to the network policy now, you can see that I created a policy to the ad service, to the CAD service, to the cart service, to the checkout service, to every service. I have my setup here, and you can see what this service is doing. It's applying to one endpoint, and that makes sense because I have one ad service. If you go, you can see that what this service is doing is allowing this ingress from endpoint from the front end over port 9555. And I think now we are ready to block all the traffic. If you see that, because the order of the default deny is 2000, it will be at the end of the default tier. So when the traffic get evaluated, it will be evaluated through the security tier, then the platform, then the default from up to down. So if the service is matching CentOS, or the traffic matching the CentOS network policy, so CentOS network policy will be allowing the traffic, and but if the traffic is not matching any of these policy, it will be denied at the end. And so from this point, I think we can apply or force. We have two options. You can do it through the YAML file, just delete the staged one and add a new one, or you can just go to the stage one and click enforce. I'm just doing that to show you how to do it from the UI. And it's very simple now. It's the same policy, but it's not staged here in the Reboot. I'm just giving you the step to delete and re-add a normal network policy. So now let's test the connectivity again. So this now I'm testing connectivity within the div and within the default namespace. So within the namespaces, the connectivity is working fine. Everything's okay. Let's test the connectivity between the namespaces. And now you can see it's not working fine when we try to connect it, giving command terminated with exit code 1 between the load generator and the nginx. So between the namespaces, this is the default namespace, and this is the dev namespace. It's not working, and that makes sense because we just allow the traffic between the pods or inside each namespace. Finally, we need to test the connectivity with the internet. We see and if it's working or not. It should not be working because the traffic is not allowed, and that makes sense. That what we did exactly. So now we achieved our target is to enforce full deny traffic and just allow the traffic between the server that needs to talk together to each other. But any traffic between different namespaces was not allowed. Any traffic with the internet is not allowed. Later on, we will start to allow specific traffic between these namespaces or to the internet. And okay, in step number 5, we are offering something called global threat feed resources to prevent bad actors for accessing Kubernetes. So the threat feed trackers is a list of known IPs of intruders that get updated daily or hourly, or whenever we have updates, it gets updated, and it blocks any communication coming from anybody in your environment to any of these bad IPs. That will be blocked, or at least will be reported to you based on the policy that you will define. So let's see here how we will do that and how we will simulate that. So here we are creating two things. We are creating a feeder tracker as a IB set. Let's see what is in this YAML file. Okay, so just this is I would say the link for the list of the IPs, where you can see I think you can see where it's updated. So it's updated today, just 1 hour ago. All these IPs is known as a bad IPs or malicious IPs. So you don't want any of your bots to communicate with these IPs. So we keep updating that automatically. And let's see what is in the okay. So this is the field tracker itself, and this is the network policy that you will create to block the traffic. Okay, so here we created something called a network set with this list of IP, and in this manifest file, we are creating a global network policy in the security tier that deny any traffic going to a thread feed called Fidu. And Fudu is a network set. I want to show you that in the UI. I think you may better understand. So, okay, so once we have a concept called a network set, a network set is a container that where you can aggregate IPs or FQDNs or CIDRs and give it a label. And later on, you can create a policy based or network policy based on this label. So this is IP set for the thread feed photo, and it includes all the IPs and it gets updated automatically, and it has some labels here. Okay, so if you go to the policy, the block photo policy, you will see that this is using this label, thread feed equal photo. Okay, this is the same label is here. So you don't need so if you want to do that manually or without the network sets, you have to create a network policy and add all these IPs in your network policy. And every time you change an IP or what you want to add an IP or remove IP, you need to update this network policy. But imagine that you have 100 of namespaces. Each namespace had its own network policy that need to connect to a certain APIs, and you set what by the network set you can aggregate all these APIs or this URL in a one network set. And if there's any update or any change to these IPs or network set, you just need to update one location, which is the network set itself. You don't need to touch the network policy itself. And this is the idea of having the network sets, and how this is how we use it with detecting something like the thread feeds or the Fudu tracker here. And we can simulate that some bad traffic. We can try to connect one of these IPs here to show you how the traffic will be blocked. Okay, I just may need to install JSON query quickly.
And just just so we're aware of the time, Joseph, I realize we're coming up to the hour. So if there's any last remarks, I guess, for the team.
Okay. Okay, I will make sure to that. Our session at hour and a half, I think, right?
It could be. Sorry,
yeah.
I got my times wrong. Okay.
I don't know, 90 minutes. Yeah.
Perfect.
Yeah.
Okay, so
we still have time, guys.
We still have 30
Perfect.
minutes. Yeah. Okay, so as you can see, we're just setting a variable any IP from that list, and we are trying to exit the CentOS and bring this IP. And let's go. Okay, I'll close that. I don't need it anymore. So as you can see, this is one of the bad IPs, and the traffic is already blocked. And yeah, we should be able to see that here very soon. But anyway, the main idea is to block that traffic, and that has been blocked already. So, and just to save time, I will continue my my Reboot, and we will back to that to see how it will work and how it will be showing in the UI. But now we confirm it that the traffic has been blocked to any of these bad IPs. We have if you, this is a kind of a bonus task. You can do it by your own if you want to try to block the traffic to our VPN. So it's the same like the thread feeds Fudu. We have a Tor VPN list, so you can apply that and see how that will be blocked and how that will be reported in the UI. And the next step that we need to use egress control to allow the traffic between specific pods and external APIs. So we have tested before that the connectivity from the div to the default namespace is blocked. And we have tested also that anything from CentOS to external resource like Google or Twilio is blocked as well. So there's no need to test that again. And but we can at the moment we need to allow that traffic. So I will apply this policy, and before or once I will apply it, I will see what is written in this policy. Okay, so this network policy allowing the traffic between the egress traffic from kubedns, this is fine, and it's allowing. Okay, so we are applying this in the dev namespace where we have the CentOS app, and we are allowing the traffic between the front end and the CentOS namespace. So by doing this, so now we are allowing some traffic between different namespaces, and we can now test the connectivity, and it should be allowed. You can see it's okay now. This is the first time we curl from the CentOS and the div to the front end, and that traffic is allowed. The next step is to use something called the DNS policy. And DNS policy, yeah, I know it could be something very easy in the traditional architecture, but in the Kubernetes Live, it's not that straightforward. So using the DNS policy, we allow you to create a policy based on a FQDN name. So we will allow you to apply policy based on Twilio, to allow traffic to twilio.com, for example. So here the policy that I will apply, and if you check that in the UI, here the policy that I have just created in the security group, and I'm allowing the traffic to twilio.com, *twilio.com, anything at twilio.com, that traffic will be allowed. That this is something very handy to have in your environment, just to allow traffic based on FQDN. And so now if you just test, we have to test just to make sure that it's only Twilio allowed. So Twilio is okay, but Google should not be okay. As you can see, it's not the traffic is blocked. And yeah, so we discussed the network sets. Then the idea of the network set, that instead of creating a network policy to specify the DNS name in the network policy, you can create a network set and add all your FQDN or domain names in that network set. And in each policy, you can just add a label of these network sets. And so that the same technique that we used with the thread feeds in the previous module. So by moving to the next module, we will talk about securing the host itself. So Calico network policy not only can secure the pod and the pod communication, but also can apply to some policy to the host. So in this example, we will see how we can restrict some traffic on the host. So I will start with exposing the front end over port like 380. Okay, so I'm just creating a node port to expose the front end over port 8080 to port to node port 380, and to test that, let me open a new window here. Okay, let me just get the name of the master node. Okay, so this is the public name, and if we create a new window and nc d refused. DV. It takes some time to be allowed, but just let me make sure that I'm choosing the correct node name. It is the same. Okay. Let's see if the service exposed correctly here. kubectl get svc all. Yes, front end node port 80. It could be something blocking on the node security from. I'm running my lab on AWS EC2 node, so it could be some restriction on the security group. But let me check again. Okay, so I'm getting a connection refused. I'm sure that this is something, maybe it's my mistake or something not configured need to be reviewed on the security group level on the node itself. But if you are testing that in your environment, you should get the traffic has been allowed, and once the traffic is allowed, you can enable host port, host endpoint, and start to run policy on that port to allow or deny a specific port on your node. So if we have time, I will come back to this module and test it with you, but that has been tested many times and should be working fine. If there's something wrong, I'm sure that this is security on the node level that I need to allow it first to be able to do that test. So moving to the next module, which is we will talk a little bit about the observability side, what we have in the UI. So if we start looking at the UI here, we have the first tab on the left. This is a dashboard. From this dashboard, you can see the total number of policies you have and total number of endpoints. And by endpoints, it could be a workload, a pod or container, or it could be a host endpoint, the thing that we have just talked about. From here, you can see number of packets per policy, the allowed and the denied packets. You can see the number of connections, allowed bytes and allowed packets. If there's any alerts, we have one alert, expecting that this is the alert. Yeah, this is what we have generated, that in the two modules. We generated some traffic to a suspicious IP listed in the photo tracker. So we are getting an alert here, and you can see that the alert is on the dev namespace here. If you are running any CIS benchmarks, it will be here. If you get the number of nodes in this view, any denied bytes and denied packets will be here in the dashboard. Forwarding from the dashboard, the policy board, we talked about the policy, how the tier is working, how you can toggle that the view. You can see connection allowed and denied and passed traffic. By default, we have a specific tier hide here called allow Tigera, that what allow the traffic between Tigera component and the kube system. You can export all these YAML files. You can add tiers from here. Anything you do it from the command line or through the manifest or using your CI/CD pipeline, you can do it. You can do it from here. And after that, we have the timeline audit. And the timeline audit is very important, especially for your compliance requirements. So any change in your system, any change in your policies, you will get this information here. So here you can see that user, which is my user, created this security policy. And it's not just that you can see what policy has been created. You can get the YAML file. You can see the audit also. This audit logs, you can see it from on the policy level. If you go down, if there's any change here, this change will be you will see it here. So if I just add port 9444, save the rule and enforce. Once you go down here, you can see that some change to the log, some change has been logged here. You can export, you can even compare and see what happened here. Okay, sorry, I just need to refresh the UI. So here's the new changes. You can see the YAML files, what has been changed. You can see that this port has been added. So you can easily figure out what has been changed. You can easily roll back the change to correct the action. So let me correct that again. Save rule and enforce. After that, you have the endpoints. Endpoints is all your ports and network hosts. You can see all the IP, the interfaces you have, the labels, the policies, what policy has been applied to this endpoint. You get the full name, the node, where this is located, in which node, and the IP address. All this information are very useful. And here you can see what nodes you have. The same information you get it for the nodes, endpoint in each node, the IPs on each node. The network sets, we talked about the network sets, the idea of the network set, which is aggregation for CIDRs or IPs or FQD ends, and giving it a label and using this label to create the policies later on. Managed cluster is the one place where you can see all your cluster, and from here you can switch between your clusters easily. And so you can connect multiple cluster from different providers, and from one place you can manage all these clusters. Flow visualization is very handy. And flow visualization is you have three circles here. The outer one represents the namespace. So from here you can switch, but you can find that the orange one represents the default namespace, for example, and the second one, it gives you the service inside the namespace. And finally, the last one is for the flow. So from here you can understand that this is the cart service has three flows. So the first one connect is from the cart to the radius cart. This is the cache, and the cart talks to the front end, and it also talks to the checkout service. So from here you can see that you have um, two green arrows. So that means the traffic, the ingress allowed, and the egress the egress traffic on the cart service allowed, and the ingress in the radius cart allowed. So that this tool is very helpful to, if you have no idea about what the developers are deploying, what is talking to what exactly. You can get a good idea here to understand what service is talking to which service. If there's any something, you can check the status here, and the status give you just green and red. Green means the traffic allowed, red means the traffic denied. So you can easily spot here what traffic has been denied, and how is the communication working inside your pods, or inside your namespace, and different between the different namespaces. The next tab is the service graph, and service graph is very useful tool here, that you can see all your namespaces and the connectivity between all your namespaces. You can just double click in the default namespace where we have the Hyperster shop. You can see that you have a front end, and it's we have the different service talking to this. Every green line represent an allowed traffic. Any red line represent denied traffic. So that easily you can draw a kind of service flow of your environment to see what component is talking to which component. From here you can easily spot if there's some service not supposed to talk to each other. You can spot that from here easily. If the opposite's happening, even you can find that easily from here. It's not just that. You have the network flow, and in the network flow you can see the time, the source name aggregation, the source namespace, the source type, the label that you have in this source, the destination namespace, the destination aggregation, the destination port, all this information. And it's Kubernetes context. It's not just a network traffic flow like the 5 aspects: source IP, destination IP, source port, destination port, and protocol. No, it's not like this. It's Kubernetes context, so it gives you the namespace, the name aggregation, the type of the destination, the type of the host, and what policies was applied here, and the number of bytes in and out, and a lot of further information. You can get the process name and the process ID, so it's very handy when it comes to troubleshooting. We have the same for the DNS, for HTTP. Any alerts will be here, as we saw the alerts for the malicious IP connectivity. You can get more information when you click on any service or any pod here. You can see what traffic allowed for source and destination, top level DNS status, because DNS could be one of the most annoying capabilities or features. So we have a kind of a graph for the top level DNS status, and any latency here you can spot it easily from that graph. In the view, you can, if you want to save this view, for example, I want to this is a Tigera component, I want to hide this component, and or maybe emphasize de-emphasize this component, and just save that. So it's a shop view, and at any time if you want to come to this view again, just you need to double click on that view. The idea of layers again, so you can create a layer and add some component to this layer. So for example, all the Tigera component are in this layer, so you can hide this layer. You can just store the layer, you can de-emphasize the layer and emphasize it again. So this is about the service graph, and I know that we don't have much time, but this is a type of the example for the alerts, where we have the IP that we have created to detect or to prevent any connectivity to suspicious IP, like this IP, which is part of the photo tracker list that has been denied and reported in the alert list. We can see that we are configuring some other list, but we haven't used it yet. To if both attempt to connect to google.com, that will be alerted. It's whatever you want to do, you can create it with the alerts. If any change happen to the global network set, that will be alerted. This is the 3 alerts that I have created in the module 1. Finally, and very quickly, we have Kibana integrated with our Calico offering that gives you a different dashboard for further information. So for the dashboards, we have like around 6 or 7 dashboards. For example, you have a DNS dashboard, the honeypot, the layer 7 dashboard, and the audit logs. For example, if we click on the DNS, that gives you further information for troubleshooting. So it's not just the information, it's everything stitched together. So you can see the amount of requests in your environment, the external queries, the internal queries, all the flow, the nearest flow logs is here. You can filter and you can troubleshooting. You get number of bytes in and out. You can export the data transfer to a CSV file. So it's very handy when it comes for troubleshooting anything. If you're troubleshooting DNS, or if you're troubleshooting HTTP traffic or layer 7 traffic or network flows, if you even for compliance, sometimes it's required to get the audit logs. So you can easily spot it here, all the audit logs, and export for a specific time or something like that. There's still, I think, one more or two module. It's just about using compliance report and for it takes at least 1 hour to be generated. So I run that, but it will be generated after 1 hour. But once it's generated, you get that kind of view about what is protected, what is not protected. And we have 4 different reports: CIS benchmark, inventory, network access, and policy audit. The last module will be the alerts. We talked about it, and the last thing that I don't think that we have time for it, but it's very straightforward, is the packet capture. And packet capture is like we run packet capture as a code here. So through a YAML file, I can in 1 minute from that YAML file, you can just run a packet capture. A resource is RD at the resource called packet capture. You select the name of the bot using bot selector, and you can add here in that YAML file that if you want to filter specific ports and in a specific direction and a specific protocol. So you can just run packet capture without the need to exit the board, without the need to get a specific privilege, without the need on the board, without the need to have like something like TCP dump running on the board to be able to run packet capture. In just 2 days ago, we released a new release that you can run packet capture and stop it and run it, and from the UI. In few days, you will be able to run packet capture and stop it and see the history from the UI here. By doing this, we reached the end of our session. Please try that, and if you have any question, join us next Thursday on the office hours to ask your questions. I'm giving. I hope we have few minutes for questions.
Right. Thank you so much, Joseph. And just a heads up for everyone, so we won't be able to address all the questions that have been asked in the Ask a Question section. However, Joseph and Nigel will be available this Thursday at Bring It On with Luke, which will be a dedicated Q&A section. So don't worry about it if you feel like we don't get to yours. So please do tune in for that session on Thursday. If you want more information about that, you can join the SUSE and Rancher community, and all the details will be there. But I'll start off with the top question over here from Sigam, which is how should we handle firewalls in cluster? Handle firewall in cluster networking if firewall is not enabled, not able to access the internet from inside pods? What setting needs to be done, or the advisable approach to keep the firewall running and also have a proper network reachability?
Okay, so traditionally, if you have a firewall in place, and definitely everyone have a firewall in place, the problem with bots that the bot doesn't have a static IP or routable IP where you can apply a policy from the firewall to this workload. So using Calico, we have a special integration with specific firewalls like Fortinet and Palo Alto. But if you are using anything else and you want to apply a firewall policy on a workload, you can use something or a technique called egress gateway. The idea of the egress gateway that you give an IP, a routable IP for a namespace. So once you have a static or routable IP for this namespace, you can apply a network or a firewall rules to allow and deny traffic to this IP, which is this namespace. Hopefully that is answering your question.
Awesome. Thank you so much, Joseph. And I'm just going to take one last question and then we're going to call it. But just so everyone is aware, Nigel actually took the time while Joseph was presenting to respond to the different questions. The last one we're going to look at over here is, does Calico only operate as a SaaS, or can it be installed as another cluster within my environment?
We have two offerings. Calico Cloud is a SaaS offering. Calico Enterprise is a full edition on-prem. You can install it in your environment, in your data center.
Fantastic. Thank you very much.
We have the two offerings, yeah.
All right. And that will be our last question for the day. But like I said, please do take a look at the comments section. Nigel actually took the time to answer it. And it doesn't have to end here. Thursday is Bring It On with Luke. It's going to be at the exact same time, 8 a.m. Pacific time, or 5 p.m. if you're in Central European time. Nigel, Joseph, thank you so much. This was an absolutely excellent session. And I'm looking forward to carrying on the conversation. And perhaps we can also go over some of the modules that we didn't have time for in this particular session. And we'll have a lot more Q&A there. So everyone that has tuned in, please do join us then. Thank you once again. Good morning, good afternoon, good evening, depending on where you are in the world. Last thing would just be, please do check out, there's one last poll. It's just basically asking how you found the session. It'd be great to provide some feedback, especially for Joseph and Nigel. Please do try out the labs that were demonstrated. The session has been recorded, and it will be available to you on demand with this exact same link. Thank you once again to everyone, and goodbye.
Thank you, everyone.